Okay, so we're going to start with our very first lesson, which is going to be 4.1. I want to bring out the Unit 1 exam formula sheet. Here we're going to have the unit circle. I'm going to teach you how to do or create the unit circle in the future, but I do give it as a reference while you're with your exams. I also have arc length, which is this formula right here, and area of the sector, which is this formula right here. Angular speed, this is the formula for angular speed, and then linear speed, which is velocity, which is this, or can be this. So when you're doing your homework, I always recommend to go ahead and use the formula sheet. There's not a lot of information on the very first one, but as we go, you will see we continue to get more and more formulas. So it'll be nice to know where those are, so when you do take your test, you're not looking for them. All right, we're going to go ahead and start with 4.1. I'm going to always have my reference sheet available, and I'll be using that to explain as well. I also will be using the TI-30X2S, this calculator. This is the one that TCC uses for developmental classes, and then some of the instructors also require it for other math classes. I go ahead and just continue with it. I will show you how to use this, so I do prefer you to have this calculator. If you don't, it's fine. Just submit the one that you will be using, but I won't be able to explain how to do the same things on your calculator as I'm going to be doing on this one. So that's the only downfall. I normally would provide these in class if you were in class with me, but since you're not, if you don't get this one, I won't be able to help you use it. But I will be showing you how to use this one. Okay, first section. Okay, and you have to bear with me a little bit because the focusing is not automatic, so I'll have to manually focus it as we go through. Angles and their measurements, that's what we're going to start with. We're going to find the degree measure. Okay, so when we're looking for a measurement of an angle, you're always going to have a ray. This is a ray, and then here's another ray. They both have the same starting point or initiating point, which is called your vertex. Okay, and then where you start with, like if you notice here, this is a starting point and this is the arrow, meaning it's going in this specific direction. This is called our initial side because that's where we start with. We start here. And then the terminating side is where the arrow is at the end. So this is going to be our theta, our angle. Now this is important because you'll see is if we're going in an up direction, that's going to be a positive angle. If we're going in a down direction, it's going to be a negative angle. Okay, so this is going to be considered our angle, and I'm going to be using a standard position if the vertex is at the origin in the XY plane. So in this case here, standard angle. Now, I do refer to a standard angle slightly different just for purposes in the class. Standard angle for me is going to be anything from 0 to 360 degrees. The measurement of an angle is positive if it goes counterclockwise. So if it goes up from the origin, that's going to be a positive angle. If it goes down, where the initial side is at the origin, it is going to be a negative angle. Okay, that's going to be important. A degree is one way to measure an angle. We're going to be mostly working with degrees right now, but in the future, in the near future, we're going to be also working with radians. Okay, one full rotation of the ray about the endpoint is 360 degrees. So if we're going to start here and we go one entire rotation, then we're going to end up at 0 or 360 degrees. Okay, so it's a full rotation. All right, so now we're going to go ahead and sketch the angles in a standard position. The first one is A, which is going to be 120 degrees. So all I'm going to do on my little graph here is I'm going to say, okay, here's my initial side, and I'm going to go 120 degrees going up. Okay. If you remember, a right triangle is going to be 90 degrees, so I'm going to go all the way through 90 degrees, and I'm going to go a little bit more. Okay, so I'm going to go a little bit more. Somewhere around there, we're going to be able to say this is 120 degrees. So this theta here, in other words, I'm going to go ahead and say theta is equal to 120 degrees. Okay. The other one is negative 70 degrees. Well, remember, here is a right triangle. This is 90 degrees. The negative tells me directional is going to be going down. So I'm going to go down, but I'm not going to go all the way to 90 degrees. I'm going to cut it off just a little bit more. So right there, it's going to be theta is equal to negative 70 degrees. Okay, so this is going to be our second angle, and I'm going to denote it slightly different by using two lines and one arrow, whereas the first one is going to be just one line. Okay, so two different angles. Okay, this one is ended up, and we're just going to recap real quick. In college algebra, you should have learned that everything in this quadrant is called quadrant 1. Everything in this quadrant here between 90 degrees and 180 degrees is called quadrant 2. And then from 180 to 270 is called quadrant 3. And then from 270 to 360 is called quadrant 4. So when we go back and look at this, we can say 120 degrees, that's going to be in quadrant 2. Negative 70 degrees, that's going to be in quadrant 4. Okay, quadrant 4. All right, let's go ahead and keep going. All right, we're going to name some of these angles here. I'm going to go ahead and say our right angle is a 90 degrees. That's exactly going to be notated as a square here. Okay, all right, straight angle, 180 degrees. From here to here, from this axis to this axis. If an angle is between 0 and 90 degrees, it's called an acute angle. And if an angle is between 90 degrees and 180 degrees, that's going to be called an obtuse angle. Okay, so we have the different measurements here. Okay, this is going to be important because it describes everything from 0 degrees to 180 degrees. The same thing would apply if the if the angle is a negative going in that downward direction. Okay, so complementary angles, you might remember this from geometry. That means that the sum of the two angles adds up to 90 degrees. The complement of 30-degree angle is, well, I'm going to go ahead and say 90 degrees minus 30 degrees. That is going to be 60 degrees. So the complement of 30 degrees is going to be 60 degrees. The supplementary angle is a measure of two angles that adds up to 180. So the supplement of 130 degrees, well, 180 degrees minus 130 degrees is equal to 50 degrees. So the supplement of a 130-degree angle is going to be a 50-degree angle. So this part I'm going to do slightly different. I'm actually going to do it both ways because I remember some of you are not going to be having this calculator. But this is why I like this calculator, because it does a lot of the math for you as long as you know how to use it. Okay, so let's go ahead and start here. A degree can be divided into 60 equal parts called minutes. 1 degree is 60 minutes, and 1 minute is 1/60th of a degree. Okay. Each minute is divided into 60 parts is called a second. So 1 minute, 60 seconds. 1 degree, 3,600 seconds. Okay? All right, so now we're going to convert to decimal degrees. Okay, so when we're doing this part, all we're going to do is we are going to start with our minutes. This is going to be 12. So I'm going to say 12 minutes divided by, well, let's do dimensional analysis. So I'm going to put 12 minutes over 1, and then I'm going to use dimensional analysis. Over here, we're going to use what we have here. Remember, when we're looking at a minute, I can say 1 minute, 1 minutes is equal to 1/60th of a degree. So if I have 1 minute, I'm going to say this is the same thing as 1 minute is 60 degrees. 1 minute is equal to 1/60th of a degree. Okay. When I do this part, all I'm going to go ahead and do is divide. So I'm going to do 12 divided by 60, and I'm going to get 0.2. Okay, so here I'm going to get 0.2. Now remember, this is only part of your answer. You still have 38 degrees. So I'm just going to add that at the end. Plus 38 degrees. So I can say 38.2 degrees. Okay. Now watch how easy it is when you're using your calculator. Okay. So in this case, we're in degrees and we want degrees. So you're going to make sure that you're in degree mode. The next thing I'm going to do is go ahead and put in my calculator 38 degrees and 12 minutes. So I'm going to start with 38. I'm going to use this button here, which has the degrees, minutes, and seconds. And I'm going to say 38 degrees, enter, 12, and I'm going to use the same button to do minutes. When you press enter here, it's going to convert it to 38.2. That's the same thing that we got here. Now you have to be careful because the degree sign is now at the end. This means that 38.2 degrees is the same thing as 38 degrees and 12 minutes. Okay? It's easier when we're going back the other way, but I'm going to go ahead and do it the math way for those of you who are not using this calculator, and then I'm going to do it the calculator way if you are using the calculator that I have. Okay? So in this case, we're going to go backwards. We're going to start with the degree, decimal degrees, and we're going to change it back into degrees, minutes, and seconds. Okay. Once again, we're going to start with the 0.45. And all you're going to do here is, because remember that's in degrees, okay, all you're going to do here, instead of dividing by 60, we're going to multiply by 60. Okay. That's going to change it to minutes. So 0.45 times 60. I'm doing it over here, and then I'll show you how to do it there. Okay. So 0.45 times 60, I get 27. Remember, this 27 is now minutes. Okay. What happened to the first part? Well, anything above or before the decimal place is still going to be in degrees. So here I can say this is 120 degrees, 27 minutes, and you're done. Look at how easy it is when you're using the calculator. Okay, so all I'm going to do here is make sure I'm in degree mode. That's one thing you're always going to want to check when you're using the calculator, is what mode you're in and what mode you want to be in. I'm going to go ahead and put in 120.45, and I'm going to put it and tell it it's in degrees. Okay, now how do I get it to degrees, minutes, second? Go ahead and hit the exact same button, this one right here, okay? And instead of going forward, because you can see here's degrees, minutes, seconds, this is our radians, this is our another form, but we are not going to be using in this class. But if you notice, there's a little arrow here saying that there's more information on this calculator. But there's only one more option. And instead of going forward, because I would have to go forward 1, 2, 3, 4, 5 times, I can hit the back key, and then I can see there's my degrees, minutes, seconds. So if I press enter here, it will attach it. Now I'm converting this degree to degrees, minutes, seconds. Press enter, and you get the exact same thing that I have here. 120 degrees, 27 minutes. Okay, so that's how we do the first part. This information right here is going to be for those who want a little bit more substance into their the information that we're learning in PreCal. So here it's saying that 1 radian, this is a little bit different. 1 radian is when the radius of the circle is the same distance as the arc length. Okay, so theta, when theta is equal to 1 radian, that means that the radius of the circle and the arc length are exactly the same. Okay, So when you think about it in terms, if you're saying, well, theta is equal to 1, that would be arc length, which is whatever distance it is, divided by the radius. Well, if these two are exactly the same, then theta has to be 1. So that's where we get this formula for. So it is really, really important that you know that when you're looking at this formula, it has to be in terms of radians. All the formulas we're going to be dealing with, in fact, are going to use theta as radians, not as degrees. So keep that in mind. Okay. In fact, if you have your formula sheet, one of the things that you should put on there is that your theta has to be in radians. So here I just make a note and say theta needs to be in radians. Okay. Now, when you're doing your homework, when you're doing your test, and you're using these formula sheets, you can't have these notes on there. It has to be a clean copy, so please keep that in mind. When you're showing your formula sheet, I'm going to ask you to show the front and back of it, and there should not be notes on your formula sheet. You need to know these basic information. Okay, so let's go ahead and continue over here. So, the number of radians in one revolution, that's what we're going to say is theta, or 2 pi. So if you notice here, that's twice. Remember, if you think of 2 pi, it's going to be the entire distance of the circle. So if you're looking at everything, okay, if you're looking at everything, it's just saying 2 pi is going to be all the way through, which means 1 pi is half a line or 180 degrees. So when we're looking at a full measurement, we can say 2 pi is equal to 360 degrees, or 1 pi is equal to 180. This is going to be our standard measurement for when we're converting from degrees to radians or radians to degrees. We're going to be able to use these. Okay. The calculator will be able to do it for you if you're using the one that I will be using during the course of this class. Okay, I'll show you how to do that as well. All right, let's go on to the next one. Okay, here it says convert from degrees to radians. So we're going to start with 120. I'm going to show you how to actually do this. You're going to do 120 degrees. Okay, dimensional analysis, I like to put the first number as a fraction, and then I'm going to change it over to radians. So I'm going to say, well, 180 degrees is the same thing as pi. Okay, is the same thing as pi. Now what you're going to do is just go ahead and use the calculator again. I'm going to do 120, and I'm going to divide that by 180. Okay. In terms of pi, we're not going to multiply by pi. We're going to actually leave pi out of this for now. Okay. When I do this, you'll get a decimal. Now, it's important that when you have your decimal, that you go ahead and convert it back into a proper fraction or an improper fraction, whatever the case may be. So how do you do that using this calculator? You're going to do second PRB. Second PRB. Second PRB is good when it's a decimal that's less than 1. Okay? Press enter, and it tells you that's the same thing as 2/3. So here what I'm going to do is just do 2/3, and then don't forget to include your pi at the end. So now we changed it from 120 degrees to 2/3 pi. How do we do this on the calculator? It's going to be very, very similar. In this particular case, I'm converting from degrees to radians. When you're using your calculator like this, you want to make sure that your mode is in what you want. Since I want radians, I'm going to make sure my calculator is in radian mode. So I'm going to change that to radian, just like that. And then now I'm going to tell the calculator, well, if I have 120 degrees, notice that here it's thinking that 120 is radians. But we have to tell the calculator, no. This is actually degrees. So I'm going to tell the calculator, yes, I know I'm in radians, but the angle I'm giving you is in degrees. Now I'm going to go ahead and press enter, and then you'll see this number. This does not look like this. And the reason for that is because this pi is an irrational number. Remember, when you have irrational numbers, those are the numbers that you cannot turn into fractions because they're not predictable. So we have to use symbols like pi or e or others, the square root of 5, for example, to represent that it's not a rational number. It's an irrational number. So if I'm taking that into consideration, I have to say, well, if this pi is in here, I want to actually take it out. Then I'm going to divide by pi. Then I will be left with just the fraction part. Here's my number. Again, second PRB, and it changes it to the 2/3. So there is where my 2/3 is. Okay. A little bit of practice will help when you're doing these. I'm going to go ahead and do the same thing for part B. I'm going to do negative 300 degrees over 1, and I'm going to change it to 180 degrees. And then over here, I'm going to say it's the same thing as pi. It's conversion. This conversion is like 1 foot is equal to 12 inches. Okay, exact same thing, except we're talking about measurements of angles. Let me go ahead and do this one here. I'm going to do 300 divided by 180. Okay, there's my number. Notice that this now is not less than 1. So we have to actually do 2 steps for this part. The first step is the second PRB. We're still going to do that. And then you'll notice that there's a little u here. Well, this is telling us that, hey, this is actually a mixed number. It's a whole number, which is the number before the u, and then a fraction. We don't ever want to deal with mixed numbers in this class. We always want to put it in improper fraction form, which means that the numerator, the top part of the fraction, is going to be larger than the bottom part. So once you have it in a mixed number form, you're going to do second and the one under PRB. And if you notice, it has a big A, B, C, which is a mixed number, and then it converts it to a DE, which is a improper fraction. So I'm going to do second, the one under PRB, and then press enter. This is the same thing as 5/3. Don't forget to include the pi back in. So there you go. Let's go ahead and try this. Also, don't forget to include your negatives. That needs to be included as well. Let's go ahead and try this on the calculator. Remember, you want radians. We're going to keep it in radian mode, and I'm going to put negative 300, and I'm going to go ahead and tell the calculator it's degrees. Press enter. I get this number. That doesn't convert into a fraction. If I tried, I can try, but it won't because of the irrational number right here. So divide that pi back out. So divide pi back out, and then you're left with just the negative 1.66666. This can be changed by second PRB. There's our mixed number. Second under PRB, and there's our negative 5/3 pi. Okay, so you're done. All right. That's converting from degrees to radians. Let's go the other way, and we're going to now go from radians to degrees. This tends to be a lot easier for most people. Let's go ahead and start with writing out what we have. 8 pi divided by 9. I'm going to multiply. Now, here's the thing. If I have a pi at the top, I want the pi to be in the bottom because we want to cancel out that pi, which means 180 degrees will be on top. So notice that all we're doing is flipping this because we want to cancel out those pi's. Now I'll just use my calculator, and I'm going to multiply everything across. 8 times 180 divided by 9. When I press enter, this is telling us it's 160 degrees. So here we have 160. Yes, I know that I'm in radian mode, but I'm only doing simple math, okay? The reason I know it's degrees is because this unit degrees did not get canceled out. Only the pi's did. So you have to carry over the degree sign. Okay. How do I do this in the calculator? Well, easy way to do it. We want degrees and make sure we're in degree mode. So let's go ahead and change that back over to degrees. And then we're going to go ahead and start and enter the radians that were given. So remember, just like what we did before, we were given degrees, but we were in radian mode. Now we're given we want degrees, but we have a radian angle. Important thing to do here is you have to make sure to put it in parentheses, because if you don't, order of operations will just make the 9 in radians and everything else will be not considered radians. So I'm going to enter in the fraction first in parentheses, and then I have to tell the calculator, hey, this entire thing is actually a radian angle. So I'm going to put it in radians. Okay, press enter. There's my 160 degrees. Okay. If you don't put the parentheses, look at what happens. If you just press up, you can delete the parentheses. Look at what happens. And this is why it's really important that you include those. This is not the same thing. It's only considering the 9 as a radian and everything else is a regular number. So just be careful with that part. We'll go ahead and do the next one by hand. Negative 1.8. Notice that this doesn't have a degree sign, so I can know that this is automatically going to be a radian. Okay, over 1 pi and then 180 degrees. Notice that we don't have anything here that pi's can cancel out. It's okay. That means we're going to be given a fraction. So let's go ahead and just put that in the calculator. Negative 1.8. Okay, times 180 divided by pi. There you go. So this is going to be negative 103.1 degrees. Don't forget that degree sign. It'll be important. The other thing you need to be careful with is how many decimal places you want. It didn't specify here. I only used 1. You can use 2 or 3 or whatever it's asking you for. That's what you want to make sure to include. Okay, so this is the part that I was actually mentioning earlier. 2 angles in standard position with the same initial side and the same terminal side. Those are coterminal angles. So if you look here on this section, you can see angle 50 and angle 410. If I'm looking from this part here to this part here, just this angle right here, that is going to be 50 degrees. It's more than 0, but less than 90, so it's going to be here. If I go around and I add a complete rotation, so this is 50 degrees plus the angle from here all the way around, that's one complete rotation, you have 410 degrees. These are called coterminal angles. I will always call the standard position an angle between 0 and 360 a standard angle. Okay. Over here, you will see it in radians. So we have theta pi over 6. That's going to be this angle right here. And negative 11 pi over 6. Well, how did I get that? You start with your angle and you subtract one complete rotation. And remember, one complete rotation in radians is 2 pi. So if I do pi over 6 divided by 2 pi, and I'm going to do it on the calculator, this is how I do it. When you're doing radians and you're going from standard angles to coterminal angles or vice versa, you're always going to just leave out the pi. Okay, remember, pi are irrational numbers. They can't really be used in the calculator. So they can, but you don't want to use that in the calculator. So I'm going to start with the 1/6. I'm just going to use a fraction. 1 divided by 6. Subtract 2 pi. So subtract 2. Okay, there you go. Change that to a improper fraction. Second PRB. That changes it to a mixed number. And then second under PRB. That's going to change it to an improper fraction, and there's your negative 11 over 6. Okay, those are coterminal angles. Right? So here we're going to say find a positive angle and a negative angle that is coterminal to the angle that we're given. Well, this is going to be an easier part. You're going to start with 110 degrees, and you're going to subtract 360. So when you're looking at coterminal angles, you're always adding or subtracting 360 degrees or adding or subtracting 2 pi if you're given a radian. That is different from reference angles, and that's different from other types of angles. So just be careful on knowing which ones that you're going to be using, okay? So I'm going to go ahead and do this using my calculator. We're going to go ahead and start with 110 degrees, trying to find it where I don't have so much light. 110 minus the 360. That's going to give us a negative 250 degrees. There's my negative coterminal angle. And then 110 degrees plus 360 degrees. All I'm going to do is change that to a plus, and I get 470 degrees. Okay, so there's your two angles, one positive, one negative. Let's go ahead and do the other one. Here, you're starting at negative pi over 4. You're going to add 2 pi. In the calculator, we're going to go ahead and do negative 1/4 plus 2. Okay, change that to an improper fraction by doing second PRB and then the second under PRB. Here you get a positive 7/4 pi. Don't forget to add the pi back in. To get our negative angle, we will subtract 2 pi. Okay, so all I'm going to do here is go back up, and then I'm going to use a negative. Press enter, and then convert that into an improper fraction. Second PRB, second the one under PRB, and here we get negative 9/4 pi. So now we have a positive coterminal angle and a negative coterminal angle. Okay, all right, let's go on to the next page. This section is kind of a lot. Good thing is you can work on it, review it as you go. All right. So this one is saying find an angle between 0 and 360 that's coterminal to the angle, to the given angle. This is what I would call, anytime you're looking for an angle between 0 and 360, you will hear me reference that as a standard angle. That's when I was saying it's very similar if we look at fractions. If I said 2/4, I'm saying, yes, this is a fraction, but put it in simplified terms. Well, that's the same thing as 1/2. So if I'm looking at an angle, I'm going to say, make it a standard angle, meaning make it an angle between 0 and 360. It will be an angle in simplified terms. I just call it a standard angle. So we're going to start with the 910 degrees. Obviously, that's higher than 360, so we're going to subtract 360 as many times as we need to. So I'm just going to use the calculator here. 910 minus 360. Oops, let me do that. And we get 550. Notice that's still pretty high. So I'm going to do now 550 minus 360. It's not between 0 and 360. So I'm going to do minus 360, and I get 190 degrees. This is going to be my answer for that question. Okay, next one, it says negative 80. Notice it's not between 0 and 360, so now we're going to have to add 360 degrees. So all we're going to do is add. So I'm going to go ahead and put negative 80. When you're using your negative, you have to use this one. Don't use this minus sign, use the one at the bottom. Okay, so negative 80 plus 360, you get 280. Okay, and that's going to be your answer for that particular one. Okay, same thing when we're talking about these. We're going to find our standard radian. In other words, a radian between 0 and 2 pi. This is a little bit harder for most students, but I'm going to try and show you an easier way to do it. When I'm doing this, I'm always looking at just the ratio, the 17/6. Don't ever consider pi, because remember, pi is out. So the ratio, excuse me, of 17/6 has to be between 0 and 2. If it's not, we're going to subtract. So I'm going to do 17 divided by 6, and I can see that that's more than 2. So I want to subtract 2 pi. So when I'm using my calculator, all I'm going to say is minus 2. because remember, we're not including that pi. So now I have a number that's between 0 and 2. Change that back to a fraction, second PRB, you get 5/6. So here the answer will be 5/6 pi. This is going to be our standard radian. Okay. Next one I'm going to do, here's our negative ratio. Negative 35 divided by 12. Obviously, this is not going to be between 0 and 2. So that means I need to bring it up. So I'm going to be adding 2 pi. Okay. When I do that the first time, you will see that you're still negative. So we're going to have to add another 2 pi. I'm just going to add 2 in the calculator. And now we have a number between 0 and 2. So I'm going to take this number and go ahead and change it back into a fraction. Okay. It is a number greater than 1, so I'm going to have to do those 2 steps. Change it to an mixed number, and then change it to an improper fraction. Here, I'm going to get 13 over 12 pi. And that's going to be your answer for that particular problem. Okay, so we're going to be doing in this part computing the arc length and the area of this. Okay, so we're going to be compute the arc length of the sector of a circle. Okay, so basically that's what S is. So if you remember the formula we had before, we had actually it was theta is equal to S over R. Okay, so in order to get this formula, all they did was times R by both sides, and they have the area. The distance of a circle is going to be R times theta. Now I'm going to go back a little bit and see if you guys remember when you were in geometry, for example, we learned that circumference is equal to 2 pi r. Well, guess what? Circumference is the entire distance around the circle. 2 pi, well, that's also theta in radians. This is theta in radians. This is 2 pi. R. So circumference is actually the same formula as your arc length. It just happens to be for the entire circle, not just a portion of it. Okay. So over here, you're going to find the exact length, then round to the nearest tenth of the unit. So all we're going to do is go to the 10th place. Okay. So let's just go ahead and solve for it. S is equal to theta times R. So theta is going to be pi over 12. That's in radian mode, which is what we want, times 14 meters. And we're going to multiply those together. That's all we're going to be doing. So we are going to multiply the pi in it because we're rounding to a tenth of a unit. So that means we need to include the pi. So I'm going to do pi times 14 divided by 12. Okay, so this is going to be 3.7. And I'm going to use the little wiggly squiggly line here and put 3.7 meters. That's the approximate length, okay, with a radius of pi over 12 and a radius of 14 meters. All right, next one. Here, notice in this one, you're given theta is in degrees. When you're using your formula, remember we went back and we said, oh yeah, theta needs to be in radians. So if you're given degrees, you have to convert your degrees to the radians. We're going to go ahead and do it like that, and then I'm going to show you how to do it easier on the calculator. Okay, let me move some of this stuff over here. There we go. Okay, so on this one, the first thing I'm going to do is go ahead and change my theta. So I'm going to say theta is equal to 20 degrees, and I'm going to change it to radians. So I'm going to do 180 degrees over pi. Okay, I put that in my calculator, 20 divided by 180. Okay, and then now I'm going to go ahead and convert that into a fraction, which is 1/9 of a pi. Okay, then I'm going to use my formula. S is equal to theta times R, which is pi over 9 times 2 feet. Use your calculator again. I'll do pi times 2 divided by 9, and you're going to get 0.7 feet. Okay, so can I use the calculator better, more efficient? Yes. All right. In this particular case, we want theta to be in radians. Look at our degree. Our mode is in degree. We're going to change that mode to radians. Okay. Now I'm going to say theta, which is 20 degrees. I'm going to say 20 degrees. Remember, it's in radians, so it's going to think it's radian mode, but you need to tell it, hey, no, it's actually degrees, times r, which in this case is 2, so I'm going to just times that by 2. Watch what happens. Press enter. You get the exact same number. Okay. This is why I actually like this calculator, and if we were in class, I would actually bring these calculators and show you how to use them, because it does save you a lot of work instead. Okay. The down part to using the calculator in this case, if you like to use the calculator, is that there's no partial credit. So you would actually have to show your work like this if you wanted to get partial credit. And if you made a mistake somewhere along there, you know, then I can give you however many points you earned based on, did you write the right formula, did you do the conversion correctly, and so forth. If you just put your answer as this and it happens to be wrong, or you rounded it wrong or something like that, you're not going to get as much credit as you would have by showing your work. So that's something that you have to consider, and you know, just weigh what you prefer to do. All right, next part here, okay, is computing the linear and angular speed. This one is one that a lot of students struggle with. This is probably going to be one of the harder ones. I'm going to do a few here, and then I'm going to go ahead and show you on your worksheet. I'm definitely going to do some of those problems for you, because that's always one that's very specific. Okay, so angular and linear speed, there is a big difference. Angular speed is talking about how many angles, in radians, mind you, over a length of time. So how fast are you rotating over time? Okay, where linear speed is a distance over time. Do you kind of see the difference between the two? There's also going to be another one where we're going to be talking about revolutions per minute. Revolutions per minute is different from angular speed. Revolutions is one whole rotation, or how many rotations are you going over a minute. It's not the same thing as an angular speed. Angular is always going to be in terms of theta, whereas revolutions is the number of turns over time, not the number of angles. Okay, it's the number of turns. So slightly different there. Let's go ahead and look at number 10. A wheel with a diameter of 1 foot spins at a rate of 40 revolutions per minute. All right, what is the angular speed? Let's go ahead and do this one first. When you have 40 revolutions per minute, I'm going to go ahead and start with that. So 40 revolutions per minute. Let's start like that. Okay, remember, 1 revolution is the same thing as 2 pi. That means 1 entire rotation or revolution is 2 pi. Okay, so we're going to be using that. Now, notice when we get to revolutions, these revolutions will cancel out. So here we're going to have 80. 40 times 2 is 80 pi per minute. Now let's look at the second part. How fast in feet per minute does a point on the edge of the wheel spin? So if we're going back to our formulas, we have linear speed, r times angular speed. So I'm going to start with that equation. V equals r angular speed. Okay. Going back to the original problem, we have a diameter of 1 foot, which means r is going to be half a foot. Okay. So let's just plug in that information. Here is going to be 0.5 feet times angular speed, which is the first part of the question, which is 80 pi per minute. Okay. All we're going to do is multiply this. So half of 80 is going to be 40 pi per minute. And this is going to be feet per minute. Okay, radians cancels out. It actually doesn't cancel, but it's already understood that it's in there. So all I'm going to do now is go ahead and put in 40 pi into my calculator, and I'm going to get approximately 125.7 feet per minute, and that matches the units that we're requesting it in, feet per minute. Okay, so we're done with that one. Let's go ahead and see the next section. All right, finally we're at computing the area of a sector. Here's our formula. Again, that formula is provided on your formula sheet. All you have to do is know where it's located. Let's go ahead and do this one. And I believe this is the last problem. Yes, it is. Okay, so number 11. A circle has a radius of 12 feet. Find the area of the sector made by an angle of 135. So I'm going to go ahead and start over here by doing 135. 135 degrees is probably about right here. More than 90. So I'm going to go ahead and put theta here is 135 degrees. Our radius is going to be 12 feet. So there's my 12 feet. So we're going to find the exact area of the sector. Round the results to the nearest unit. So we're actually going to find two of them. We're going to find the exact and we're going to find a rounded value. Okay, let's go ahead and start with area formula. Area is equal to 1/2 r radius, which in this case is 12. So I'm going to substitute 12 feet here. And I'm going to square it times 135 degrees. Remember what I said about formulas. Theta needs to be in terms of radians. So you're going to have to do one of two things. You're going to have to convert the 135 to radians, or you can use your calculator, which is what I'm going to do in this case. I'm going to start off by using the calculator, and I'm going to say 0.5 times 12 squared. Don't forget it's squared. And then 135. Now remember here, it's in radian mode. We need to tell the calculator the angle I'm giving you is actually degrees, because it'll do the conversion for you. When I press enter, there's our approximation. Okay, so here area will be approximately 169.6, and then it's feet squared, because we have two of them here. Okay, how do I get the exact value in this case? Remember, this includes a pi from theta, so all I'm going to do is divide by pi. I'm going to take the exact value and divide by pi. When I do that, I get 54. So the answer here would be area is equal to 54 pi feet squared. This is the exact value. This is the approximation. You can also do it the longer way by using the conversions, which I'm going to go ahead and do just for completion's sake here. We're going to do area is equal to 1/2, 12 feet. I'm going to square that, 135 degrees. I'm going to go ahead and convert that 135 to radians. Okay? When I do this, you're going to get the exact same values here. I'm going to go ahead and do it longhand. So it's going to be 144, which is 12 squared, divided by 2. We're going to get 72. So I'm going to go ahead and do 72 feet squared. 135 times divided by 135 divided by 180.75 pi. Okay, don't forget the pi is right here. So now I'm going to multiply these two together. So 0.75 times 72 times 72. And there's my 54. So here's going to be my 54 pi feet squared. And then the approximation would be 54 times pi. So times pi. There's my approximation. Area would be approximately 169.6 feet squared. Exact same thing that I got over here. Just one is showing your work, the other one is using the calculator's capabilities. All right, that concludes 4.1. I'm going to go ahead and go on to 4.2,